In this video, I'm going to introduce you to the programming language called Python. Now, there's the term language in there. It's much like a spoken or written human language. Now, you don't learn a new language by picking up a dictionary and memorizing all the words in the dictionary. No, you start using it, and the same applies to Python. You've got to start using it, and we're going to start using it not too long from now. But there are a few basic concepts that you have to know about. So I'm going to take roughly about an hour and just introduce you to some of it. Now, don't run away. Some of it's going to look difficult and some is a bit odd and strange and unfamiliar. You don't have to memorize anything and you don't have to understand everything in this hour. Look at some of the concepts. Try and just familiarize yourself with them. It actually is quite easy and it's quite a bit of fun. Open that Google Colab notebook and let's get started. And we are back here in Google Colab, and Python in a few minutes, as you can see, is the name of my notebook there. Remember, you can just click on there and the name, at least on the left side of this dot for the IPYNB file, you can just hop over there, change it whatever you like. It's clinical research. You see there the three logos. Don't worry, I'll show you how to do those logos before this course is over, but it's brought to you by myself, my research group at the University of Cape Town. Although this is for everyone, it does follow the same chapters as we have in the Coursera course on understanding clinical research. So Python in a few minutes, can it be done? So remember, this is not learning the whole language. We're not sitting with a dictionary when we try to learn a new human spoken language and just learn all the words from the dictionary and then we can speak the language. No, we're going to start using it. And as we start using it, everything becomes clear and really relatively easy. But there are a few basic concepts that we have to understand, I think, before we go. So this is going to be very simple introduction, but it's going to give you enough so that we can just start doing our statistical analysis once we get going. So let's just start with simple arithmetic. Now we see on the right top side there, my Python 3 Google Compute Engine backend is already running. We see the RAM and the disk size there versus what is available to us. So it's already running. So I've done a new code cell here, remember? So I'm just going to hover there and hit the code cell. And we're going to start entering some text. And what I've done here is 2 space plus space 2. We've seen this before. 2 plus 2. We know that it's 4. Now, remember our little hashtag symbol here. When we write a line of code, that means tells Python everything after this, please ignore that. So we can write it here at the end of our code because the 2 plus 2 is still going to be seen by Python, still going to be executed, but everything after this hashtag is going to, Python is going to ignore that. So hold Shift and Enter, as you can see there on a PC and Linux machine, or return on a Mac to execute that cell. Remember, we can also just hit this little play button. So I'm going to play it, it gets sent to Google. Google's massive computers executes that for me and sends me the answer back and displays right here in my browser, and the answer is 4. And of course, we needn't just stop with just the 2 numbers. It's just a massive calculator is what Python is here for us, 2 plus 2 plus 10. And of course, the answer is going to be 14. Subtraction just as easy, that's the minus symbol on a keyboard. And if I shift enter that, shift return that, or hit the play button, 7 minus 4 is 3. We have looked at this before. Remember, there is no multiplication symbol on a keyboard, most keyboards that I'm aware of anyway. So we use the star symbol, that's shift and 8 on most keyboards, certainly shift and 8 on my keyboard. So if I want to do multiplication 3 times 4, that is going to be 12. Division is the / key. Again, there's no division symbol, at least not the one that you learned about at school with a line and the dot on top and the bottom. There's nothing like that on the keyboard, so we use the / key. So if I want to divide 3 into 14, and otherwise 14 divided by 3, 14 is the numerator above the line, 3 is the denominator below the line, 14 divided by 3, and we're going to get this numeric representation of the solution. This is just a representation of the solution. This is not an exact solution. The exact solution is 14 over 3. If you keep it in that fraction, that's the exact solution. But we get this numerical approximation. So it's going to truncate this long string of 6s with a 7, which means it's 4 2/3. And that if we were to write 14 and 2/3, that would be the exact solution. But here we get this numerical approximation. We also get integer division. Remember, that's the whole number that you want to have. So that's that 4 that we can see there. So for that, I'm going to use 2/ symbols. That means 3 goes into 14 4 whole times, and there's going to be a bit of a remainder to get from 3 times 4 is 12. To get to 14, there's a remainder of 2. And to get to that remainder, if you're interested, I'm just showing you some of these mathematical symbols. That's the percentage. If we just use the percent symbol there, that's the remainder. So 3 times 4 is 12, plus another 2 is 14, and there you get the whole concept of division right here inside of Python. Powers, sometimes we want to take something to the power. Again, there's no specific way to write powers, the small little superscript there. So we just use in Python 2 asterisks, 2 little star symbols. So 3 * 2 means 3 to the power 2. And of course, 3 times 3 is 9. So if we execute that, we should see a 9, and indeed we see a 9. The order of execution, that is something that you must remember from school. Remember, some of these operators should be done before others. So multiplication and division come before addition and subtraction. So if I were to write 3 + 4 × 2, it's not going to go from left to right. So it's not going to say 3 + 4 is 7, and 7 times 2 is 14. That would not be right. Multiplication comes before addition here. So it's going to say 4 times 2, which is 8. And if we add 3 to that, we should get 11. Let's see. And indeed, we get 11. If my intention was to do the addition first, I just use, as you did at school, we use the parentheses. So I'm saying the parentheses come before multiplication in that order of execution. So it's going to be 3 + 4 is 7, times 2 is 14. And now I'm going to get the desired 14, which might have been my original intention. So here's a little exercise for you. 6 + 4 × 2 divided by 10. And my intention is to do the addition first. So if you want to pause the video, just do this little solution. If not, I'm going to show it to you right now. So there's our solution. Remember, if I double click on that, it's 3 little hashtag symbols, meaning it's the third from the larger size, 3 down, 2 down to get to the third one. And our hidden cells there, I can just toggle on that, and it hides that for me, and it opens it for me again. And there's the solution. 6 + 4, I put that inside of a set of parentheses. So that gives me 10. Then it's going to multiply by the 2, but all of that is inside of another set of parentheses so that I can do this whole numerator first, and then I divide by the denominator, which is 10. And that should give me 2, and it's a 2.0, so that's a floating point number. So in basic terms, that is the mathematics that would be on any calculator. Now I'm going to say a quick word on functions. Most of what we do in Python is based on functions, these keywords that are built into the language. And if we import other modules or libraries, we get even more. And that's fantastic, that ecosystem. And that's how we're going to do our statistics, by the way. But everything is based on these functions. A function is it's a keyword, it's protected. So you can't use it to do anything else. You shouldn't. You can, but you shouldn't. It's built into that, and you're going to pass this function something, and it's going to do something with this input that you gave it. And remember, we call these inputs arguments. Some other languages call them parameters. In Python, we call them arguments. Suppose you can call them parameters if you wanted to. But we pass this to the function. The function knows, based on what you give it, the type of thing that you give it, and it'll do something to it. So here we have the print function just as the single example, just to belabor the point and to tell you about these definitions like arguments. It's going to take an argument, and remember those arguments are always going to go inside of a set of parentheses. And in this case, this argument that I'm giving it is a certain type, and the print function likes that we give it a specific type, and this type is a string, and string go inside of quotation marks. We've heard this before. So I put that this is easy, full stop, and I put that in single quotes. So that makes it a string. The type of that thing that I'm passing to print, the type of the argument is a string, and print likes those type of arguments, and it can do something. And the thing that it's going to do, it's going to print whatever I pass it to the screen. So there we can see this is easy. You see it's stripped away my quotation mark, my single quotes there. So it's just printing that string, that sentence back to the screen. So that's a function and an argument. So only one I'm going to show you because, as I say, this is not reading the dictionary. You're going to hear the word dictionary again, by the way, but let's hang on before we get there. You're not reading a dictionary to learn the new language. I'm just telling you these are the concepts, and we're going to see plenty of functions as we go. So I mentioned this thing that we passed, this argument, as a certain type of thing. It is a string. And certainly there are many data types inside of Python, and Python is fantastic in this way. It has many data types, and it knows what to do with certain data types. And it is all about this thing, and we're going to call it a thing for now, this kind of thing that we're passing. And we have this function called type, and if we pass something to this function type, it's going to tell us what type this thing is that we pass to it. So this thing is an int, short for integer, a whole number. And if I write 3.0 and I take the type of that, for us human beings, 3 and 3.0 is exactly the same thing, but for computer it's not. That's a floating point number, which is just another term for a value with decimal points. So 3.0, that's a floating point number. And remember I said something like, put inside of quotation marks, that is a string. Let's see what that's called, str. That's the type of it. So if you're ever stuck in something's not working for you because perhaps it is the wrong kind of type that you are passing, just look at the type function. Remember, the type function is very quickly going to tell you what type of thing you are dealing with. In this instance, we're dealing with a string because it's inside of these quotation marks. Now, I mentioned before, very quickly, we're talking about libraries and modules, and that's a way for Python to extend itself. So the base of Python, we're standing at this 3 series of Python, and 3.8 is out when I recorded this. It contains a bunch of functions, but we want to do more than this. What is system base Python? And so there's this whole community around Python that just develops extra libraries, and that just adds a bunch of new functionality, including functions, to base Python. But we've got to import them first. By the way, Python is an open source. It's free of charge, and people work on it free of charge. So people take some of the free time and develop these modules. Some people do work for companies that do support them in the development of these, but this is a fantastic community. Let's carry on. The math is a module or a library that we can add to Python, and we add it by this import function. So you're going to see import quite a bit. So import math. Math is the name of the library. It contains a bunch of functionality and functions, extra functions. So we just say import math. And when we do that, we have access to everything that's built inside of math. So one of the first things to look at is those weird and wonderful irrational numbers. The first one is pi. You can see the beautiful pi symbol there. If you want to know how I got that pi symbol there, let me just lift the veil on that. It's a text cell, and you see these little dollar symbols on either side. That is something called LaTeX. L-A-T-E-X. Latex, but call it LaTeX. And that is a type of code, and it is for typesetting and very useful for mathematical typesetting. So if we want to write mathematics on a document, if you want to send it for publication and you want nice mathematical symbols and formulas and equations and expressions in there, use LaTeX. So inside of Python, in the notebook here, we use these dollar symbols to indicate that we are going to now pass some LaTeX code. And pi is a specific symbol inside of LaTeX, and these specific symbols have forward slashes in front of them. So it's going to be /pi, pi. And if I execute that, we just get pi. So that's not part of Python. I'm just showing you that is possible. What we are interested in, of course, is the value of Python itself. So there's a pi keyword inside of the math. And to get to these extra ones, because they're not part of Python itself, we have to reference the library or module from which it came. So we have to say math, and then a dot, and then this new functionality that we want that is built inside of this library or module. So math.py, I can't just say pi. There's a way just to say pi, but we won't get there yet. So I'm going to say math.py, and there I see the value for pi at least to a couple of decimal places. Euler's number, E, you might know it of, math.e, another of these absolutely phenomenal irrational numbers, just like pi, absolutely incredible values these. I just have to say math.e and I get the representation of math.e. Now we can also use the exponent function, exp, you'll see that a lot, more than you'll see the .e there. Exponent is exp, exponent is the e itself, Euler's number, and we're just raising it to the power 1 because any number in mathematics that you raise to the number 1 just stays that number. So we're just saying exponent 1 e to the power 1 as I've written for you there. Let me just lift the veil on this little one because LaTeX is sometimes it's fun. It's e, and then we get this Shift 6 caret symbol on my keyboard, and then 1, and that caret means write a little superscript in LaTeX, so I get this very beautiful e to the power 1 there. And anyway, if I say math.exp and I pass the argument 1, I get exactly the same thing there, Euler's number. Trigonometric functions, we're not going to use them inside of data analysis much, but it's just math.sin, S-I-N, the mathematical abbreviation that we always use for the sine function. And I want to do, as you can see here, sine of pi over 2. Let me just open that for you. You can see how that happens. So that's backslash sin, that tells LaTeX it's sine. And then I have the set of curly braces on the outside because I'm going to do something after the sine function. And the / frac means fractions. And then 2 sets of curly braces, the numerator and the denominator. In the numerator I'm putting a pi, in the denominator I'm putting a 2. This is all just fun. It's not part of Python, but I just want to show you it's fun. So it's math.pi for the Python. Remember, division is the /, so pi divided by 2. And if I take the sine of that, of course, the sine of a half pi is just 1. These are done in radians, by the way, if you remember that from school, not in degrees. So cosine is math.cos. And you see a very funny looking answer here, 6.123 e negative 17. So that's 6.123 times 10 to the power negative 17. If you remember anything from scientific notation, that is all the 0, all these zeros until the 17th place we have a 6. So 0.00000. This is rounding errors that are made for very specific reasons and within very specific constraints. And because of these constraints, that we have this representation, and you can just think of it, 0.0000, that's basically 0. That's what Python is just trying to tell us there. It's just 0. That number is just 0. And suddenly, the cosine of 90 degrees, pi over 2, is just 0. Logarithms, don't worry about those too much. That's certainly those kind of round-off errors never going to bother us in our statistical analysis. At least not what we're going to do here. So if I want to take the natural logarithm, if you remember what logarithms are, sometimes some schools dropped the teaching of logarithms at school, some still have it. You might know what logarithms are. We certainly can deal with logarithms inside of statistics. It's much better, I suppose, today to use what we call non-parametric tests instead of these transformations, log transformations. If I'm talking weird words here, don't worry, we'll get to that. But I can take the natural logarithm of e, and of course, the logarithm just says whatever the base is. I'm dealing with a base of e here. It asks e to the power what gives me 1. Well, e to the, or gives me, the natural logarithm e is just 1, e to the power 1. If I want the natural logarithm base 10, it's asking there, 10 to the power what gives me 1,000? Well, 10 to the power 3 gives me 1,000, so log base 10 of 1,000 should be 3. Let's see. Oh, 3, it is indeed. Square roots, just as simple. It's the sqrt function, so math.sqrt, and I pass a value of 256. So what's the square root of 256? It's 16. So a very simple little exercise for you now. Maybe it's also time for you to go get something to drink or whatever. This is going to be a slightly long video. I want the tangent of pi over 4. Okay, let's have a look at the solution. I can just pull that down, and yes, I'm sure you would have guessed this is math.tan, T-A-N, and I'm doing math.pi divided by 4. And let's see what the tangent is of pi over 4. And you again see this numerical representation, 0.9999, that's 1. Python's just trying to tell you that it's 1. Later on, we'll have a look at how to do a round off. So if I were to round that to 2 decimal places, of course, the answer was going to be 1. Good. Let's move on to something very, very important. So we've done with the basic calculator that you have on your phone and used to have in physical form. I still have a very fancy calculator in physical form. I just love the thing, still love to use it. Computer algebra system calculator. Really still fun to use. Anyway, a computer variable. Now, a computer variable, you can describe this in different ways. The way I want you to think about it is this name that you give to a space in your computer's memory. You're going to name that little physical space inside of your computer's memory. You're going to give it a name. And you give it a name because then it sort of gets locked down and you can start putting stuff into it. Meaning you can assign things to live inside that piece of memory so that you can use it over and over again. And I've been using the term things all along. That is a bit cringeworthy. What we actually put inside of that piece of memory is called an object. Everything is basically an object. Even these arguments that we pass as an object. And what we get back is an object. And these objects have types. And we've looked at the types before. So the type of just 3 was integer. But that 3 was an object. More correctly, it was an instance of the class, of a certain class. But not to worry about that. It's an object. And I place this object inside of this piece of physical memory in my computer and I give it a name. And that's much easier for us to do than writing the whole physical address in all sorts of weird and wonderful code in real computer speak. I just give it a name and that makes things very easy. Now, there's some constraints to this, these names that you can give. And it's just best to start off a name with a lowercase letter. No numbers, no uppercase letters, etc. You can use underscores, etc. But just start with a lowercase number, stick to the basics, and make it very descriptive. You're going to view your code later on, so you want to give a variable name something that's descriptive. So just looking at the variable name tells you what you stored inside of it. And the most common thing to do is just to string a bunch of words together. So my computer variable name is my variable name. And you see I put underscores there because spaces would be illegal characters. We can't use illegal characters. Space in Python means something very different, or can mean something very different. So I have to concatenate my words together, but my variable name is very descriptive to me. If I say mean of group 1, and I just put these underscores in between that's easy for me to, when I look at the code or give it to someone else, mean of group 1 or group A or mean of placebo group. You know, if you name your variable something like that, everyone knows what you're talking about. Now that's called snake case because we're just creating this little snake of words. And then less popular is camel case. Now in other languages like the Wolfram language, which I also teach, uses camel case. And that is where we put the words right up, bunched up against each other. We save some typing by not having to put the underscores. We start with a lowercase, but every subsequent word is uppercase, just so that when you look at it as a human being, you can still kind of see that these are different words. So you would write my new variable like that. But certainly in Python, it's much more common to use the snake case. And please don't use the Python functions, the built-in things. Don't call your variable print or type. That is a reserved keyword, a reserved function inside of Python, so don't do that. So let's get a few done. Here I have my value, my underscore value, and I'm using this equal sign. Now the equal sign you have got to get used to. That's called the assignment operator. That's not the equal sign from school or from math, definitely not. And we're going to say my value equals 3. That actually reads, create a piece of memory, just allocate a piece of memory, call it my underscore value, and assign an object to it. So I'm actually just putting this inside that bucket. I'm physically assigning what is on the right-hand side to what is on the left-hand side of that assignment operator. That's what it is, an assignment operator. So I'm saying pass this object 3.0. This object is of a certain type, remember. It is a float. I'm going to assign this float to this piece of my memory, and I'm going to call this memory my underscore value. And that my underscore value, that is what we refer to as a computer variable, just some name. So let's assign that. There we go. And now there's a little piece of the memory inside Google's computer, not mine, that has an instance of an integer object, and this object has a value 3.0, not integer, I should say float, and it lives inside of this piece of memory. Now I can just recall it by just using the name. So if I just type my value, it's going to go look in that piece of memory, and whatever object is stored in there, it's just going to give back to me. And we can look at the type of my value, just as we looked at the type of 3.0, and it says my value, that computer variable, is storing a float object. Lovely stuff. Now, one more thing about this assignment operator that you must be aware of, which is one of these quintessential things. As I say, that is what this video is all about. I'm just showing you these basics. We're attempting just to read some words in the dictionary, but later on we're just going to use it, and these things will really become second nature because they're really easy. I'm going to create this computer variable just called I, and I'm free to do that because that's not part of Python. It's nothing that is kept by Python. I equals 0, so I'm using the term equal, but that's not what it says. It says assign whatever's on the right-hand side of me to what's on the left-hand side of me. To the right-hand side of me is this integer 0, and to the left-hand side of me is a computer variable name, so I'm assigning the 0 to I. And I can just on the new line type I, that's just recalling it, and it's going to print 0. That's what is inside of it. Now I want to give I another value, but it's kind of an update value. And if you read that sentence, I equals I plus 1, that line of code there, this one here, let me highlight it, I equals I plus 1, let's just increase the size, I think it's a fair size, I equals I plus 1. That makes no sense because in algebra, if I take the I to the left-hand side, that becomes I minus I, and that's 0 equals 1, and that's certainly not true. Because remember, as I said, this is not an equal sign, this is an assignment operator. So what is on the right-hand side? On the right-hand side is I plus 1. What is inside of I at the moment? Well, the value is 0. And if I add 1 to 0, I get 1. So on the right-hand side, I actually have 1. And now I assign it to what's on the left-hand side. On the left-hand side is the computer variable I. It already holds something, but that's not cast in stone. In your computer, you can rewrite stuff over. You can delete something and store another document, delete a document, create another document. So it's not there, it's not chiseled in stone inside of the silicon. No, we can just write over it. So remember, on the right hand side I now have 0 plus 1, that's 1, and I'm assigning that new value, that new object, I'm assigning to the computer variable on the left hand side, which is I. Now I equals 1. Okay, so that's a beautiful example of this not being an equal sign. And just to show you, people are lazy and there's all these little shortcuts. Instead of writing I equals I plus 1, we also just write I plus equals 1. That's just shorthand and you'll see it everywhere. And I just wanted to show it to you in case you saw it somewhere and didn't know what it meant. So what's happening here now, that I plus equals 1 is the same as I equals I plus 1. I at the moment is holding a value 1. I add another 1 to it, that's 2. And now I'm reassigning that to I, so I is now 2. As simple as that. So another little exercise. Time for a break, but you can certainly attempt this, pause, come back to the video, whatever you want to do before we move on to list objects, which is another one of those important things. So we're going to create a computer. I want you to create a computer variable to hold the string. This is easy. Recall the computer variable and confirm that the computer variable indeed holds an object that is a string. Off you go. So here's the solution. Simple. Twirl that open. You could have given it any name you want. I called it my underscore string. That's descriptive enough for me. And I'm assigning to it what is on the right-hand side here. And that is a string. And it says this is easy, full stop. And so I now have that. If I want to recall it, I just use the variable name. And it's going to return to me whatever is in there. See, now the quotation marks are still there. I'm not using it inside of a print function. Although I could also now have said print, parentheses, my underscore string. Then I would have gotten back, this is easy, full stop. And the type of my string, if we were to do that, is just a string. It's a string object, str. Great stuff. Now let's move on to objects. Collections. And first one we're going to look at is list objects there. So a list object is just something that we can do to store more than one element. Before, we've just used single values, 3.0, one single string. This is easy, full stop. Now we're passing more than one thing, and the first or the most common thing we have in Python is called a list. And we indicate the fact, there are more than one way to do it, but the common way is just to use square brackets. Square brackets 1, 2, 3, 4, 5. So I'm passing 5 elements, or creating 5 elements, I should say, inside of these set of square brackets. And that is just a list. And there we go, we have a list, and if I just type it in like that, it's just going to return that list. It's not saved in memory in a computer variable, nothing, it's just that. Now I needn't just stick to the bunch of integers there. Yeah, I'm mixing an integer, a string, and a floating point value, all in the same. And if I asked what is the type of this thing, and I'm still using the square brackets there, so what is the type of this whole thing, not what's inside of it, but the type of the whole thing, it's a list object, as simple as that. So let's create a list object, but this time around, we're going to store it in a computer variable, and very descriptive there, very original, I'm calling it my_list. And I'm passing these I have these 4 elements inside of this list that I create, and I assign that to the computer variable myList. And let's recall my list, and it's just that list object that we get back, with the elements 1, 2, 3, 4. Now another useful function is just the len function, Len, and it's short for length. So it'll tell me how many elements is inside of my object. My object is a list. The length knows what to do. This is actually shorthand for something a bit deeper, but that's not what we're interested in here. It's a function len. We pass to it an argument. That argument is this object, and it's called myList, and it counts. There are 4 elements in there. Beautiful. Now we're going to get something called properties or attributes and methods. So if we've created an object will have certain things about it and things you can do with it. It's built into this object that you created, or an instance of this class. And one of them is a method. And we get to that method by the dot notation. So first I'm going to use my computer variable myList, which now contains this list object. And then I say dot count. And count is now called a method, but it looks very much like a function, because it is really just a function behind the scenes. So it's my_list dot count. And because it's a function, but we now call it a method because we're using the dot notation after an object, we pass an argument to it there, which is 3, and the count function is going to look at my list, and it's just going to count how many times whatever I pass to it occurs in my list. So I'm asking there, how many times does the value 3 occur in my list? And it just occurred once, because remember the elements were 1, 2, 3, 4, so 3 just occurred once. Great stuff. So that is a method, and we're going to see a bunch of methods. Most of what we're going to do are going to be methods, but just think of them as functions that you put at the end instead of at the front. We'll see some attributes later, or properties. An attribute, it just tells you something about that object. It doesn't have parentheses, and you don't pass arguments to it. It's just some property that we can elicit, and we'll have a look at some of those a bit later. So let's create another one that's a bit more complex. I'm creating my other list, very original there. And it's a list object, and I have these 3 elements in it, and 2 are integers and 1 is a string. If we look at the type still, though, it's going to look at the whole thing and just tell me that it is a list. Slightly more complex, again, I can pass lists as elements of a list, and that's called a nested list. So I've got this outside set of square brackets, but inside I have 2 sets of square brackets, and each of those are lists. So this is a nested list. I've got list inside of a list. And that's completely allowed. No problem there whatsoever. If I now do pass my nested list, which my computer variable that I created, by the way, if I pass that to the len function, what are we going to get? We're going to get 2, because it takes it from the outside. And it's seeing those nested lists inside of it as a single element. So I've got these 2 nested lists inside of. There are ways that you can drill down, and we'll get to that. Now we can certainly add to a list. Remember, my list was just 1, 2, 3, 4. If I want to add to the end of it, I use the dot append. And what is that append? It is a method. So it's like a function and I can pass an argument to it. So I'm just saying append, which is good English for saying just add something. So I'm going to add a 5 to the end of it. And if I now look at my list, lo and behold, the 5 is now going to be added to it. Just a fun little function is the pop function. And the pop function is going to pop off an element, and it's going to pop off the last element. And when I just do it like this, it is going to show me the element that is popping off, removing. It's the 5, because if I now look at my list again, I'm only back to the 1, 2, 3, 4. Excellent. Now we come to indexing and slicing. Indexing is a very important part of Python. And if you can think, if we have a large data set full of healthcare information, we will only want to extract certain patients or certain data. We don't want all the data when we analyze it. We are after making groups, analyzing subgroups, etc. So slicing or indexing, let's use the term indexing, very important. So let's just recall what is held in my other list. And we see it was 1, 2, 3, 1, 2, 3, but the 2 was a string. And the thing about a list is that every element inside of a list has an address, just like you have an address. And we can reference those addresses if we want to get to those values, the values of those elements. One of the things about Python that you must learn is that Python starts counting at 0. It's 0-based. So the first element is actually the 0th element. It has an address of 0. The second one has an address of 1. The third one has an address of 2, and it's all a bit of fun. So the 3 addresses there would be address 0, address 1, and address 2 for those 3 elements. And we use addressing by square brackets as well. This has nothing to do with a list. This now square brackets means something completely different, because I write the computer variable there, my other list. There we go. Square bracket 0. It says give me the value that is in address number 0. And because Python starts counting at 1, that's going to be the first element inside of my other list, and that is the 1. So if we want the second element, I have to pass the address 1, and that is the string 2. Beautiful. Now, instead of listing all the ones that I want, I can also create this little range, and this range says give me values from 0 to 2. Now we've got to be very careful here. See the colon symbol there? That indicates to Python that we're asking for a whole range of values. And from the 0th value, the 2 there is exclusive. That's one way to look at it. So it's going to go up to address number 2, but it's not going to give me address number 2. The other way to look at it, well, let's just stick to this way. I think that's the easiest way to have a look at it. So it's actually going to be 0 and 1. The 2 is not included. The 0 and 1, the 0th element and the first element. In our little list, my other list, it was the 1 and the string 2. So you can ask for this range. I don't want you to try and memorize this now. I just want for you to be aware of the fact that this exists. And as we start using it, you'll see how much sense it makes and actually how easy it is to use. There's a little shorthand that I want you to know about, and that's the -1. That just indicates give me the -1 means the end element. Now it's easy to see here because we've only got 3 elements here, but if you have an enormous data set, you just want the last value. It's very easy not to have to then know what its address is. Just type -1, and that's going to give you the last one inside of the list. Now remember, my nested list, it had 2 nested elements in it, and so we can use these 2 sets of square brackets. So the first one says give me the first element, 1 with an address of 1. That means it was the second nested list, and then give me the first value or the 0th value in that. So if I scroll back up to my nested list, well, what we can do, let's just recall it here. So I'm going to insert a new code cell. I'm going to leave myself a comment to say recall my nested list, and then let's just type my nested list. There we go, my nested list. There we go. And if we recall it, it was a nested list of 2. So the first one, the 1, 2, 3, was the 0th, and the first was the 3, 4, 5. So I'm saying give me that second one, the 3, 4, 5, and in that the first element, which was the 3. As simple as that. Now we can also use indexing to change the values. So I'm saying the last one, change it to 4, please. Remember I said it's not chiseled in silicone stone. We can change the values. And now the last one is 124.0. And you see I passed a little dot there. I don't have to put the 0 in Python. I can just say 4 dot. It's exactly the same thing. But now I've changed that value. One other thing I want you to be aware of is the double colons. And that just says up to number 2. But 2 again is excluded. So it says start at the beginning and give me up to 2, but exclude 2. So that's the 1 and the 4 as we've rewritten my other list. Now for the other way around, 1 till, so that's going to give me the second element till the last element, the 2 and the 4. Great stuff. An exercise that I want you to do is the following. Create a list with 10 elements from 0 to 9. Now you can look it up, there's a very easy way to do that. You don't have to type all the numbers, but for now we're going to type all those numbers. Use indexing to print the first 5 elements of the list, and use indexing to print every second element. Now that I haven't shown you, but maybe you can figure it out. Let's have a look at the solution. So there's the solution, my list, and I've had to type all of them there. As I said, there's an easier way. Maybe you can look it up and see how to do that. If I want the first 5, that's going to be 0 to 6. Remember, because the 6 was excluded. And the one I didn't show you, if you wanted to look it up, you would know how to do this. But here's the solution. You can use another colon, and that colon is going to be 2 in this instance because it says start at 0 and skip. Give me every second one. And that's as simple as that. Now I'm going to get the 0, the 2, the 4, the 6, and the 8. Now that was lists. I've introduced you to lists, and we are going to see lists again. Let's move on to tuples or tuples. Which way you want to pronounce it. Perhaps tuple, because 2 sounds like tuple, and it sounds like 2. But tuples are actually n tuples, n, where n stands for any number you want. You get a 3 tuple and a 4 tuple. That will be 4 elements. Anyway, here we are creating a 3 tuple, or then a tuple. And what we tell Python that it is a tuple or tuple by putting it inside of parentheses. So here we have 3, 5, and the string 2. And there we go. 3, 5, and 2. Now, these certainly have addresses, but the beautiful thing about a tuple is the fact that I can give each of those elements a name, a computer variable name. So I'm going to say 1, 2, 3, because I'm just separating those 3 computer variables. My tuple, assign my tuple to those. So every element inside there is now going to have this very descriptive computer variable name. So if I were to type 1, it's going to give me back that first element, which was 3. And the same for 2, it's going to give me back the 5, and 3 was going to give me back the string 2. So I can name tuples. Now I can also pass tuples to the length, and that's going to give me the length of 3. I can use the same indexing. One thing I'm not showing you there, but I really want to tell you about it, tuples are cast in stone. They are what we call immutable. Whereas lists are mutable, we can change the values of the elements. Tuples are immutable. You cannot change them. When you've created them here, that value is going to stay the way that it is, and there's good reason to have this functionality. Now we're going to move on to dictionaries. Now dictionaries are going to become very useful to us. We're going to use them in a slightly different way. It's actually just going to be what underlies what we're going to use, but it's good to know just what a dictionary is. And where we had square brackets for list, we had these parentheses for tuples, we have curly braces for dictionaries. And dictionaries are just pairs of values. The first one of the pair is the key, or the name of it, and the second one is the value. So these are key value pairs. And we separate the key and the value by this colon symbol. So on the left is the key, on the right is the value. So my key is language, and it's a string key, and my value is Python, and it's also a string value. Comma is the next one. My next key is version, and it's a string, and my value is 3, which is an integer. Then I have another string as a key, and another string as a value. And you can mix these up of any types or almost any types. So there's my underscore dict for my dictionary, and I can get to the keys by using the keys method. Remember, the method is like a function. So I'm just saying my underscore dict dot keys, and it's going to give me back the 3 keys that I had, the language, the version, and the environment. If I want the values, I say that use the dot values method, and then I see the 3. If I want the whole item back, I just get dict dot items, and I get language Python version 3 environment notebook as this list. I mean, that makes it a list, and this makes it little tuples. So key value pair are actually little tuples. Now, if I just want to get the value back of one of the keys, so the value of the version key was 3, so I just have to say my underscore dict dot get, and I'm going to get that back. There is the alternative syntax. Remember, I said right in the beginning the other ways to create lists instead of using square brackets. That was just shorthand notation. And certainly here you see with dictionaries that those curly braces were just shorthand notation. It underlies, or it will behind the scenes convert it to this format. It uses the dict function. So everything is going to go inside of a set of parentheses, open and closing parentheses. There you can see them. And what we're passing to dict is a list, and it's a list of tuples. And the tuples are the key value pairs. So that's actually what's happening behind the scenes, just if you're interested in that. And there we can see what we've created. Next up, by the way, remember you can always hit pause and come back. This is a long video. And I said it's just a few minutes. In the end, it's going to be a long few minutes, but still it is just a few minutes. Sometimes we want to iterate over code. Just repeat the execution of that code a couple of times. That becomes very useful. And the 2 ways to loop through things are these 2 concepts that I'm going to show you in Python, the for loop and the while loop. So let's start with the for loop. It really reads like English. I'm going to use this little loop to loop through the values 0 to 9. Now, inside of it, let's just break it down a little bit before we get to the proper structure. There's this range function. So a function inside of Python, and I'm just passing one single value to it. If I pass a single value to it, it's going to start at 0 and go up in steps of 1. So it's going to be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. It's going to stop at 9. It's not going to include 10, but if you think of it, if you start at 0, you are getting 10 elements back. So that's the other way to think about this, that indexing I said before. But let's look at the whole for loop. So let's say for I in range 10, print I. Now for means we're going to loop through this. I is just some placeholder I'm using now. That's got nothing to do. This is internal to the for loop. So it's just a placeholder. It's saying for I in range 10. And remember, range 10 is going to create this list for me, which is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's going to loop over each of them and then print that one to the screen. Let me show you what it looks like. It'll make more sense. And there we get those 0, 1, 2, 3, 4, 5, 6, and 8, 9. Everyone is printed as we loop through those 10 elements. So another way to make it very useful, if I say my underscore other underscore list, remember that was 1, 2, and 4, I'm going to loop through these elements in my other list and print them. So for element, now element is just some word I came up with. It's just some placeholder inside of this for loop. Outside of this for loop, nothing. It's just this placeholder. I could have put I there as well, or some other word. I'm saying for element in my other list, print element. I'm going to show you what it looks like before we get deeper into the construction of this for loop. And there you see it's just going to loop through, print element, and each element is just a separate one. As I say, that element word has got nothing to do with it. I could use any other word in there. It's just the loop counter, basically. But look at the structure of the for loop. I'm saying for and in. Those are very important. So I've got to have the for and I've got to have the in. I've got to have some counter name, just some name that you choose. And then the thing that contains many things inside of it. So my other list contains it's a list and it contains 3 things in it. Then I've got to put a colon. And if you put that colon and hit enter, you're going to get this white space here. See that white space? The P is not under the F. That's very important in Python. This is set by default, the number of spaces it puts there. In other IDEs, that's development environments, programs in which you can write the code, you can set how many spaces are in white space. This is all done by default here in our Google Colab, but it really means something to Python. That white space, I can't delete that white space. Then things are not going to work for us. Okay. Something else I could loop over are the keys in a dictionary. That is something that has elements in it, and I can always loop over elements. So for key, again, that's just the word I chose. For key in my other dict.keys, there's going to be those 3 keys, print the key. So that would be another way just to get back those 3 keys. Okay. The while loop is going to execute something while something holds. Some constraint holds. So I'm going to create a computer variable called I. Remember, that has nothing to do with that name that I choose there to loop over, the I there. So I'm going to create a computer variable I, and I'm going to assign to it the integer 0. And then I'm going to use the while loop and then some condition, because I'm going to keep on doing this loop until this condition is no longer met. So while I is less than 5, print I, and then I equals I plus 1. So let me just show you what it looks like. So 0, 1, 2, 3, 4. So at the beginning it's 0. Is 0 less than 5? Yes, it is. Again, the colon, and see the white space. It's going to be created automatically for you. Print that I. At that moment, I is 0, so I'm printing 0. And then increment I by 1. So I is 0, add 1 to it is 1, reassign it to I. Now I is 2. Now we loop back. Is 2 less than 5? Yes, it is. I can continue with this loop until I get to 5. Is 5 less than 5? No, it's not. Python's going to execute that while loop, and it's done. It's done for. So here's your exercise. I want you to loop over the following. Create a computer variable called myString and assign the string object. This is easy, full stop to it. And then I want you to loop over each character in the string and print it to the screen. But I want to give you some tips. Remember the range function? We just said range 10 and then gave us 1, 2, 3, 4, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If I say put 2 numbers in there, it's going to go from the 0 to the 5. But remember the 5 is not included. So it's going to be 0, 1, 2, 3, 4. But it's a range object. So if I pass that to the type function, see that it's a range object. But I can loop over this range object, just as we did with the 10. So for n in range 0 to 5, print n. That's going to print for me the 0, 1, 2, 3, 4. That's 5 elements, but it excludes that 5 because it starts counting at 0. So that's one tip for you. The other tip for you is, remember, if I were to write the word Python inside of quotation marks, that makes it a string. I can index that string, and so I can say, give me the last one back. That's just the n. So the solution I want you to come up with must include these tips, please. So let's have a look at the solution. So I'm going to create the string object, myString, create the computer variable myString, pass to it, assign to it whatever's on the right-hand side. On the right-hand side is the string. This is easy, full stop. I'm going to create a new computer variable to hold the length of that. So this is easy. Let's do this. Let's just type myString len as well, so we can just see how many it counted. myString len. So if I do that, I'm going to get 13. There's 13 characters inside of that string. So now I can just loop over each of those. Remember when I showed you the -1? It means each of those characters inside of the string actually has its own little address. So I can say for char, and char is just the word I came up with. You can have used I again. You could have said for I in range. And that's 0 to myString length. And remember that's 13, so it's going to go 0, 1, 2, 3, 4, 5, 6, 7, 8, 12, up till 12. The 13 is excluded, but if you start counting at 0, that's the 13. And then I want you to print myString and then address each of the characters in turn. So if we print that out, we're going to say this is easy, full stop with the spaces in between, all of them. Great stuff. Now, in the while loop, we used conditionals. So I just want to show you something about conditionals. And these are if, elif, and else is the one that I want to show you. Again, this is just to show you that this exists. If any of this lecture is just too strange for you, don't worry about it. As we start using it, it's going to be easy. If you learn a new language and I just take some random value, number or word, I should say, from the dictionary, it doesn't make sense. And until you've used it a couple of times, it's difficult. So this is just introducing you to some concepts. So I'm going to create a computer variable called I, and I'm going to assign the integer 23 to it. And now I have this if-else concept going on here. So the if I is less than 20, colon, because if I hit enter, I'm going to get this white space. It means something to Python. So it's going to look at this conditional. Is I less than 23? What is I? It's 23. Is 23 less than 20? No, it's not. Under those circumstances, what comes here will be ignored, and then it'll jump to the else statement. And this else, if I hit enter here, I'm going to get that white space. So I can't start typing else there. You physically have to remove that white space because the E and the I, the E and the I, the E of else and the I of if have to be right under each other. So if I is less than 20, print smaller than 20, else, colon, so that there's white space. Very important to look at the structure. Come back to it and look at it often. Print equal to or greater than 20. So indeed, that is what is going to happen. Equal to or greater than 20. That smaller than 20 was not going to execute because the conditional was false. 23 is not less than 20. Now you can keep on with these. You can add more conditionals as you go. And in between, we put in this elif. It's short for other languages which use the full else if. But in Python, it's just elif. So let's make a equal to 2. We assign 2 to the computer variable a. We assign 1 to the computer variable b. Now I'm going to say if b is greater than a, colon, print b is greater than a. Do you think that's going to happen? Is 1 greater than 2? No. Elif a equal b. Now that's a new conditional. We've never seen that one before. So the double equal symbol there, that is a conditional. It says, is what is on the right-hand side to me equal to what is on the left-hand side of me? And it returns a true or false. All these conditionals return Boolean values. We haven't discussed those, but it says true or false. So is whatever's on the left of me 2 equal to what's on the right of me? 1 says 2. No, it's not. But if it was, it's what's going to print A and B are equal. And then in the end, if all of these things fail, do something else. And that is print A is greater than B. Is 2 greater than 1? Yes, it is. So guess which one is going to be printed to the screen? A is greater than B. And it's a beautiful, very simple example for you to figure out how if, elif, and else statements work. So an exercise for you. It's a computer, and I've put an example exercise there for you because these last two things, I just want to make something fun. It's a famous computer task, and if people go for interviews, they might be asked just to create this, just to check if they understand the language. But it's a fun little thing. So it's a task we're going to say, take the numbers 0 through 21 in this case. And for each number, if it is divisible by the integer, say 3, and divisible means there's no remainder. It will go into it completely. Then print the word foo, F-O-O, and if there's a remainder, print bar. And this is one way to go about it. I'm just showing you one way to go about it. For I in range 22, so that's going to be 0, 1, 2, 3, 4, 5 up till 21, which is exactly what we want. If I percentage 3 equals 0, so remember the percentage means that I just want a remainder. And if something is divisible by, the remainder is going to be 0. So it's going to start at 0 and it's going to say, is 0 divided by 3, does that have a remainder of 0? If so, print I, that number that we are at the moment, and then print foo. Now, you see something new with a print function here as well. I can concatenate stuff inside of the print function. So here I'm printing the value that's an I at the moment. It'll start at 0, then go to 2, then go to 3, then go to 4, and then a comma, and then a string. So with commas, I can concatenate lots of things in a string, and I'm concatenating it by a little space, a colon symbol, another space, and foo, just so that it prints nicely to the screen. And if the remainder is not 0, so if it's not divisible, print the value and then print bar. So it's going to run down all of those and just do the foo bar thing for us. So foo, remember we said if it has a remainder of 0, and otherwise bar. So 0, 1 or 2 won't be. 3 is divisible by 3 with a remainder of 0. 6 is divisible by 3. 9 is divisible by 3. So simple as that. The last little fun thing, I just want to show you something called list comprehension. And list comprehension is like a little for loop, but we put it inside our square brackets. This is just some advanced stuff, just some fun for you to have if you're interested in it. My underscore set equals I for I in range 51. So I for I in range 51 inside of square brackets, that's going to be a list object for me, and I'm just going to print those first 5 elements, 0, 1, 2, 3, and 4. I could say I for I in my set if I %3 equals 0. Now I'm getting the same sort of thing in a much shorter sentence. Now if you look at that, that is a bit advanced. That is like some hectic syntax or grammar inside of a spoken human language. But I want you to look at it and see if you can dissect what is going on there. And as I say, I'm just showing you this for a bit of fun. And let's do the following. Print the square of the number if it is divisible by 5. So I squared for I in my set if I %5 equals 0. That's how I would construct that. So now it's going to print, it's going to first select only the values that are divisible by 5, and then it's going to square each of them. I hope you find that as interesting as I find it. But as I say, it's not part of this course. I just want to show you some of the power of Python and how you can construct something very complex, basically. So take all these values, see if they're divisible by 5, print them to the screen, but square them at the same time. That's a short line of code, and once you get the hang of it, it's actually quite easy. So that's my couple of minutes introduction to Python. Again, maybe I have thrown the dictionary at you, but that's not the idea. You don't have to remember any of this, because it's only when we start using it that it starts making sense, that it'll get into your head, and you'll see just how easy it was for me just to write this little notebook. It's from a long time of usage, not from looking at it for the first time, so don't despair. All of this is easy, and as we start using it to do what we're actually here to do, and let's do some statistical analysis on healthcare data, you'll see just how easy all of this really is.